Before we dive into the statement, it's far more persuasive to sort out what molecular gasoline pedals are. The Big Hadron Collider, LHC, operated by CERN, is a 17M ring of superconducting magnets. In addition, it's the world's most prominent and most noteworthy atom smasher. It represents the pinnacle of human achievement. As a matter of fact, it's so powerful that it could reproduce the precise states of the first moments on Earth. But could the system intended to open the mystery of the universe hold the key to something truly specific? Founded in 1954, CERN is one of the world's most famous research institutions. With 23 member states and countless researchers, it's a place for collaboration and innovation. The LHC is CERN's principal undertaking, but it is only one part of a large organization of gas pedals and tests. Consider a route not for automobiles or people, but for subatomic debris. In a trial of aptitude, patience, and space itself, the LHC accelerates protons to almost the speed of light, sending them on a collision course that reflects the energy of the universe right after the Big Bang. The impacts create temperatures much hotter than the core of the Sun. A massive number of magnets guide the protons on their journey, while complex cooling structures keep the magnets at temperatures colder than space. The beams in the LHC are made to crash at 4 locations around the gas pedal ring, connecting with 4 particle detectors: Atlas, CMS Alice, and LHCb. Each fills a specific purpose, investigating different components of particle physics. Together they act as large cameras, taking pictures of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also referred to as the God particle, and other anomalies that could provide clues about the universe's essential building blocks. By focusing on the microcosm, we gain insights into the universe. But with every solution comes another question, and with every discovery another challenge emerges. The LHC is not just a scientific instrument, it's an exhibit of human curiosity and progress. It represents our entrepreneurial mission for knowledge and our desire to understand the key forces that shape our universe. But as we push the limits of what we know, we must also consider profound and existential questions. Within the sacred halls of CERN, where the boundaries of human knowledge are constantly pushed, a revelation has arisen, one that sends a shiver down the spine of even the most pro-scientists. Brian Cox, a former scientist at CERN and a voice of expertise in particle physics, recently made a statement that has left the world both enthralled and uncomfortable. Cox's words resound with chilling clarity. The purpose of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a small version of the very event that gave birth to our universe. The physicist also went on to explain the ramifications of this aim, highlighting the LHC's immense potential for making new discoveries. This includes its ability to uncover the secrets of the Higgs boson and explore dark matter, a mysterious substance that makes up a vast portion of the universe. Imagine holding the power of creation in your hands, the capacity to summon the very essence of the universe. It's an attractive possibility, but one fraught with danger. The mini Big Bang isn't just a theoretical idea. It's a very real phenomenon within the LHC. The temperatures, the pressures, the raw energy, everything recreates the conditions of the universe's birth. It's like standing at the dawn of recorded history, witnessing the birth of life itself. Yet with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky encountered a disaster that would forever change the course of his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, a failure caused his head to accidentally enter the direct path of a proton beam. The beam, with a force that defies perception, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky saw a flash brighter than 1,000 suns, but had no immediate concerns. The beam's path left a trail of destruction, burning tissue and bone, but he remained conscious and even walked to the center for treatment. The outcome was both troubling and remarkable. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, Bugorsky's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a reminder of the immense power and potential dangers of particle accelerators. The dangers of a particle smasher like the LHC are not to be underestimated. The potential for catastrophic reactions, the very fabric of existence being altered, these are not the stuff of science fiction but real concerns voiced by respected scientists. One of the most unsettling and captivating concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are giant vacuum cleaners, devourers of stars and mysterious entities lurking in the shadows of our universe. The fact that the LHC could potentially create such a phenomenon, even on a small scale, is awe-inspiring to both the public and scientists alike. Scientists at CERN have reassured the public that any black hole created would be unstable and disappear very quickly. Nonetheless, the remote possibility has sparked debates, fears, and a sense of awe at the energy we wield. It's important to understand how the LHC might create a black hole. It's all about the basic mechanics of particle accelerators. When protons are smashed together at almost the speed of light, the energy produced is so immense that it distorts the fabric of spacetime itself. Imagine a trampoline stretched tight. Then a heavy object is dropped onto it. The material bends, and if the object is heavy enough, it could create a well so deep that anything nearby could be drawn into it. This is an analogy for what could happen at the LHC. In the realm of quantum physics, where the laws of the universe are both strange and wondrous, there's speculation that extra dimensions might be hidden within our reality. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. In his book, Stephen Hawking warned of a scenario in which the Higgs boson could become unstable at very high energy levels. This instability could lead to a catastrophic event known as vacuum decay, an event that wouldn't just destroy Earth but could potentially erase the entire universe. The renowned English cosmologist and astrophysicist Sir Martin Rees has also expressed concerns about the experiments conducted at CERN. In his book On the Future, Prospects for Humanity, he explored the potential dangers of particle smasher experiments, including those at CERN. His words weren't just cautious, they were filled with a sense of existential dread. Rees examined a worst-case scenario in which a failed experiment could trigger a phase transition, a catastrophic event that would ripple through the fabric of spacetime, resulting in a disaster that could engulf the entire universe. However, he also assigned a low probability to these catastrophic outcomes. Nevertheless, he argued that even a small chance of such an event warrants serious attention. After all, when the stakes involve the fate of the entire universe, the margin for error must be razor-thin. Safety measures and scientific reassurances. The scientists at CERN have run simulations, analyzed theories, and taken every precaution to ensure the safety of the LHC. In fact, Brian Cox himself has emphasized the importance of these safety measures. Acknowledging the inevitable concerns and questions surrounding the LHC's activities, he reassured the public that there are rigorous safety protocols in place. According to Cox, the energies involved in the LHC experiments are well within what the Earth naturally experiences. The chances of creating a stable black hole are astronomically low. Even if a black hole were created, scientists argue that it would be so tiny and volatile that it would deplete rapidly in an explosion of energy. This phenomenon, known as Hawking radiation, was predicted by Stephen Hawking himself. In essence, any black hole formed at the LHC would be a fleeting moment of cosmic wonder, just a brief glimpse into the void and then gone. The LHC, extra dimensions, and the gateway to the unknown. Some have taken the idea even further, speculating that the LHC's experiments could open a gateway to another universe or even another dimension. While this idea is largely dismissed by mainstream scientists, it has captivated the imagination of many and become a subject of intrigue, fear, and even fantasy.